evening. Just a second. Hope you're all doing good. How are you? How are you all? So welcome to Unacademy, India's largest online learning platform, which is helping the students to gain more knowledge and reach their destination. Welcome all of you. Yeah, today is a analog electronic crash course. So it's supposed to be from Monday to Saturday for 4 p.m. Because of the time constraint, we have moved half an hour ahead. That is to complete the portion as early as possible. We have moved half an hour ahead so that we can crack the exam more accurate. With more accurate, we can crack the GATE exam. Right? Analog electronics is here. I am with you. Right? Let's move on. So this is the analog electronics course, which will be useful for the students of electronics and communication engineering, electronics and electrical engineering students, as well as instrumentation students. All three branches students, this course is very much important, right? So this is also important for ESE also. Okay, this is a crash course and we'll discuss problems on diode circuits. So this is going to be the last class on diodes. From tomorrow we'll start discussing about bipolar junction transistor. So almost all we have discussed many problems here. If you need any more clarity on many different problems, just post a comment and post your question. So if you can post your question, I can reply. Hope you are listening to me. Just say hi. Just say hi who are online. Just say hi or good evening or good afternoon, whatever you want. You can just say so that I can acknowledge that you are listening to my classes. Hello everyone. Hello everyone. Okay. So myself, Shravan Kumar, having master's degree from JNTU-H in VLSI system design. I have 10 plus years of teaching experience. I can teach subjects like EDC, analog electronics, digital electronics, and EMFT. Most of the EDC for 40 hours I have already taught on YouTube, and the remaining I'm continuing on next 30 classes. I'm continuing on Unacademy app. So this by the end of this month, I'll finish complete EDC and analog electronics in 30 to 35 hours. 30 to 35 hours, most 35 hours. 35 hours on YouTube. So that is going to be hit the students who are targeting for 2021 GATE. Targeting 2021 GATE students, right? Okay. And digital and EMFT we will teach for 2022 and 2023. 2022 and 2023. So we will start EMFT for 2022 and 2023. Okay. So I have a special code for you. It is called SVS10. SVS10 to get 10% discount on plus subscription. To get 10% discount on plus subscription. Sir, what do you mean by plus subscription? What do you mean by plus subscription? So plus subscription is very simple. It is you can attend live classes. You can attend all the crash courses. You can attend the weekly test. This is very important, sir. Writing weekly test, as time and again I'm mentioning, weekly test is more and more important, right? And we'll have something called doubt solving sessions. We'll have something called doubt solving sessions. So every fourth hour is going to be a doubt solving session for all of you, right? The sessions will be in English and Hindi. So you have something called a rank improvement batch. Those who are strong in the basics and they want to improve their core, improve their rank, they can join this plus subscription, right? So along with this plus subscription, we have another subscription called iconic subscription. What are the benefits of having iconic subscription is, along with the benefits of this plus subscription, you are going to have a personal coach. So who will guide you? Who will guide you clearly how to prepare the GATE examination? How to prepare the GATE exam. This is the most important thing. So you need a guide, you need a guru, you need a guide so that you can achieve more, so that you don't do any mistakes. So for that you need a personal coach. And then you have something called a study planner. This guide and study planner will almost 50% of success will come from this. If you have a good study planner and you have a good personal coach, you are done. Your 50% of your job is done. And then you have a study books, how to improve your study, number of hours, all these things will be given through regular guidelines. Okay, and then you have something, you have, just a second. Okay. Okay, sorry. So personal test analysis is there. Personal test analysis there, which will give you in-depth analysis for the test by section and by question type. A very detailed analysis will be given for all of you. Okay. Then you have something called preparatory study material, which is very much important for a student to crack the gate examination. Okay. So moving on to the next stage. So the plus subscription student is for the students who want to go for plus subscription. They have three options: 12-month subscription, 18-month subscription, and 24-month subscription. Right? The fee structure is going to be for 12 months it is going to be 27,225 rupees. For 18 months it's going to be 34,650 rupees. And for 24 months it's going to be 39,600 rupees. For everything, you have a single code called SVS10. You have a single code called SVS10. So SVS10 is a code. So SVS10 is a code which will be useful for all of you. So that will get 10% discount on plus subscription. 10% discount on plus subscription. So similarly, we have something called iconic subscription. Iconic subscription is going to be for 12 months and 24 months. So for 12 months, you're going to have 45,225 rupees. And for 12 months, 24 months, you're going to 67,600 rupees. So the codes are again same. That is SVS10 and SVS10. These are the two important fee structures for iconic student. Sir, I would suggest you to go for a 12 months and 24 months iconic subscription. This is very less cost when you go for a offline gate coaching. You go for an offline gate coaching. Very, very good, sir. Very, very good. Very, very good. Okay. So how to get that? The best thing is first download this app, Unacademy app. Unacademy learning app you need to download. So once you download the app, there will be a hit install button. Once you click on the install button, your software, that is Unacademy learning app, the app will be installed. Once the app is installed, what you need to do is you need to manage your goal. You need to choose these things, whether you are NEET PG attending, GATE ESE or IIT JAM, CSIR UGC NET or NDA UGC NET, what not. So out of which you need to select this GATE and ESE. Once you select GATE and ESE, you will have some another button called plus subscription button. So once you hit the plus subscription button, you will get subscribed and you will be taken to the step number 4, step number 6. That is that for 12 months or 24 months. There you need to enter this SVS10 code, so that you will get a subscription. Once you get the apply the code. Once you apply the code, you will get the fees and you will be given the payment methods. You will be given the payment method, which includes the 10% discount after this applying the code. Okay, so you can pay using debit cards, you can pay using EMI, you can pay using UPIs, wallets, and net banking, whatnot. All these things are available. You can pay through anything. Okay, yeah. I request all of you to follow me on Unacademy, and this is my user ID. You can just follow me using this. Okay. Next, so next which is very much important, is Unacademy combat test. Unacademy combat test is going to be on 12th of January. That is tomorrow, 12th of January from 6 p.m. So you can register now for free, but you need to use a code called SVS10. That is my promo code. If you use this SVS10 as a code, you can attend this combat test. So what do you mean by this combat? Is it is India's largest gate examination, that is online gate examination, which is every fortnight we'll conduct. For every 2 weeks we're going to conduct this. And this will be there for 65 minutes. Simply 65 minutes. And the questions will be designed by the original best educators. You will feel that they are really a gate problems. You'll feel that they're really great problems, and you can go for live compete with the best. So across India, you can compete with the best, and then you will be given a live leaderboard. How fast you are responding. For a one problem, for one question you will be on top. For second problem you will be in the second or the third, whatever. Or again you can go to the top. So you'll have a lot of fun while writing this exam, right? And the best benefit here is for every question you will be given a detailed video solution. You will be given a detailed video solution, which is very important. And what the for who are eligible to attend this exam? So the students who are writing mechanical, those who are in mechanical engineering, civil engineering, EE, that is triple E, electrical and electronics and communication engineering, CSIT, all these students are important. So the first rank, what the rewards? The first rank student will be given a 3 months GATE and ESE plus subscription. The rank 2 and 3 student will be given 1 month and GATE ESE plus subscription. And then for rank 4 and 100 will be given 500 Amazon voucher. 500 Amazon voucher. Okay. So this is the problem which we need to discuss. So, but we'll see what we discussed in the previous class. So what we discussed in the previous class is so we have discussed some few important things on Zener diode. So you can see this is what Zener diode we have discussed in detail, and we have seen the problem. This is an important problem which we have discussed. And Zener diode, this is a very important thing which we discussed, how Zener diode acts as a voltage regulator. How Zener diode acts as a voltage regulator, which is very, very important. We have discussed. That is 3 conditions we have discussed. That is when we input and both of them is fixed. For input and load resistance are fixed. When we input and load resistance are fixed, we have seen. And we have also seen what if input is fixed and variable resistor RL. Input is fixed but resistance is variable. Okay, and we have seen what if RL is fixed and variable input. Input is variable, load resistance RL is fixed. Input is variable and load resistance RL is fixed. Okay, and we have seen a few problems. I think the best of the best problems we have seen. And this is another problem which we have discussed. Problem number 3 also we have discussed. 3 problems I think we have discussed on this important concept. Right? I think I have posted this the notes also in the Telegram channel. I've already posted this notes on in Telegram channel. Okay, now coming back to today's problem. So this is very important. Today's is very important. So what is there here is asking us to sketch the output voltage. So you can see here what is there. Here diodes D1 and D2 are connected back to back. That is what type of diodes are Zener diodes. These two Zener diodes having the cutting voltage of 5 volts. Having the cutting voltage of 5 volts is there. Now is also saying I think this is not cutting voltage. I should say this is a breakdown voltage. The 5 volts is a breakdown voltage. By mistake, I have told you 5 volts is a breakdown voltage, and this is also 5 volts is a breakdown voltage. And he also mentioned the cutting voltage. When can we have cutting voltage, sir? Cutting voltage will exist in the forward bias condition, because the Zener diode acts as the normal PN junction diode when it is forward biased. But when it is reverse biased, in breakdown, it acts as a constant voltage supplier or voltage regulator, right? And he also said V input is equal to 10 sin omega t, and he's asking us to sketch the output voltage. Just to recall. So how this PN junction diode works. So in the forward bias condition, You'll have this. You'll have this as a normal PN junction diode. In the forward bias condition, it acts as a normal PN junction diode. But when it is reverse biased, so at one point of time, we should say there is a sudden increase of current. There is a sudden increase of current. That is called breakdown voltage. Breakdown voltage. You can see here, or not even this. So you can have actually a straight going line. You'll have a straight line. You'll have a straight line like this, and we call this as a V breakdown. V breakdown. V breakdown voltage. V breakdown voltage. So, but in case of forward bias condition, what is saying, sir? It has a cut-in voltage of 0.7 volts. So we are least bothered how a diode works when it is forward biased, but we are very much bothered about how the diode works. So you can see here, this is the breakdown region. We should say this is a breakdown region. We can say breakdown region. In the breakdown region, what happens, sir? Irrespective of the current, you will have some IZ minimum, and I should say IZ maximum. This is going to be IZ maximum. Just for my sake, I'm writing this IZ minimum, IZ maximum. And but this voltage is some breakdown voltage VZ. This is some breakdown voltage VZ. Some breakdown voltage VZ. Okay. So now whenever, I'm sorry. Now we should see, you should see here the two chances. One chance is as these two are connected back to back, only one diode will be forward, one GNR diode will be forward biased, other GNR diode will be reverse biased or in breakdown. Reverse bias or in breakdown. So which is very important, we should see. Are you there? Just, sir, this is very important problem. Very important problem. Are you listening or not? Sir, very important problem. Sir, if you understand this problem, we will also see another beautiful problem based on same concept. This is also sometimes it was asked in the previous gate examination. Okay. Okay, now we'll see what happens when for the positive half cycle of the input, what happens. The positive half cycle of the input, what happens. As it said, it's going to be 10 sine omega t. So first we'll try to sketch the input waveform so that we'll have some clarity on this. So for my convenience, I'm trying to draw this input and output waveform. Ravindra, good evening. Ravindra, welcome. Okay. Now we will see, assume that this is going to be the input waveform. Now what he's asking, sir, is asking us to sketch the output waveform. So for the first time, what we need to do is, first we should consider the positive half cycle. That is saying, for the positive half cycle, now there is a chance that we have to, just now I told you is, when this has to be forward biased, means this should be in breakdown. Unless and otherwise, what happens is, let us say, assume that this is forward bias. This is the forward bias. When this is the forward bias, now what happens, sir? You may think that this is reverse bias. So when this is forward bias and this is reverse bias, what happens, sir? There's no possibility of getting an output waveform. There's no possibility like that, right? Now we will see what happens if for V input, so to make one diode on, one diode is breakdown. So now consider this VZ1. I should say, can I call this as the D1, so that it is very easy for me to pronounce. So D1 and D2 are the two diodes. So assume that the D1 is in cutoff and D2 is in breakdown. D1 is in cutoff and D2 is in breakdown. So D1 in on condition and D2 is in breakdown. breakdown. It means what, sir? It means what, sir? I'll try to redraw this. I'll try to redraw this so that you'll understand what I mean. What I mean. This is going to be V input, and then here is going to be V output. So whenever the diode D1 is on, it acts like a 0.7 volts. And whenever this is the breakdown, its voltage is going to be 5 volts. So if you can see now what happens here, V output is going to be 5.7 volts. So when can V output is going to be 5.7 volts? Unless and until it is supplying this same voltage. Unless and until supplying same voltage. So this is possible only when for V input greater than 5.7 volts. 5.7 volts. When the V input is greater than 5.7 volts, then only your V output is going to be 5.7 volts. It is constant. It is constant, right? So this is D1 is on, the D2 is in a breakdown. This happens for this. So all this happens because when the input is positive cycle, input is in the positive half cycle, is in the positive half cycle. For the positive half cycle, this is going to happen. That too, when the V input is greater than 5.7 volts. When the V input is greater than 5.7 volts. And for the next step, what we need to do, sir, we need to find out for negative half cycle. For negative half cycle, so it means what? See, now I'll come back to this diagram again. So for the negative half cycle means this D2 will be on, but D1 should be in breakdown. D1 should be in breakdown. D2 is in on condition. D1 will be in breakdown. So now we'll consider that for the negative half cycle, assume D1 is breakdown. D1 is in breakdown condition and D2 is on. So if you try to draw the circuit now, this is 0.7. I should say 0.7. This is plus and minus, and similarly this also will give you minus 0.7. This is 5 volts. I think I've interchanged this. These two voltages will be different. Yeah, understood. Just now I understood. Do not worry, yeah. Okay, this is going to be 0.7 volts. And this is going to be 5 volts. Now, what will be the corresponding output? It's going to be negative half cycle V input. Output is going to be minus 5.7 volts. Minus 5.7 volts. Are you able to understand or not? It's going to be minus 5.7 volts. Okay, now for what values of the input this is going to be 5.7 volts, sir? Whenever V input is, this is like reverse engineering. When V input is less than minus 5.7 volts, so V output is going to be minus 5.7 volts. So for the previous case, for V input is greater than, for V input greater than 5.7 volts, so V output is going to be 5.7 volts. Okay, so now here for V input less than minus 5.7 volts, V output is going to be 5.7 volts. Now tell me what happens in between. So this is very important. This is very important discussion. Now, for V input lies between 0 point, sorry, excuse me, this is going to be minus 5.7 to 5.7. Now come back to this problem, and you can see here Focus on here. Focus on here. Now, for V input, like let's say for V input at 0, because I am taking some reference voltage here. For V input lies between minus 5.7 to 5.7. So for V input, for V input is equal to 0. Consider V input is equal to 0. For V input is equal to 0. For V input is equal to 0. Now what happens? Can this diode becomes on? No. No. When this diode is cut off, is this current is flowing in reverse direction? No. That is also not possible. So both diodes current is not flowing. For both diodes the current is not flowing. So these two diodes are considered as open circuit. These diodes are considered as open circuit. These diodes are considered as open circuit. When these two diodes are considered as open circuit, what would be the output voltage? So now the final one is so D1 off and D2 is also off. Both of them are open circuited. Both of them are open circuited. You can see here, this is open circuit, this is also open circuit. So this is going to be V input, this is going to be V output. It's going to be V output. This is going to be R. So if you neglect the voltage drop across the R, so V output is going to be V input for the condition. V output is going to be V input. V output is going to be V input. V output is going to be V input. So how do you sketch? How do you sketch, sir? So consider a voltage. Consider a voltage which is this is what is saying, sir, 10 sin omega t. It means plus 10, and this is going to be minus 10 voltage. This is going to be minus 10 volts. So here you need to consider two voltages. For two voltages, this is going to be plus 5.7 volts, and this is going to be minus 5.7 volts. Plus 5.7 minus 5.7 volts. Now what happens, sir? Your output is going to be like this. I'm trying to draw on the same so that please bear with me. My handwriting, it is just not as straight as possible. So it is a 2-level clipper. Bharat, good evening. Good evening, Bharat. You are late, yeah? So you missed one problem. You missed one problem. However, to your friends, ask them to join. Ask them to join. Please ask them to join as early as possible. We are discussing very, very important problems today. So, and today is the last class for diode circuits. From tomorrow, we'll jumping into the transistor, BJT, bipolar junction transistor analysis. Okay. Yeah. Okay. It's 3:30. Hey Bharat, I have already told you that from Monday it will be from 3:30. From Monday it will be from 3:30. I think I have told you. Did you miss it? Did you miss that? So this is only one problem we have discussed. Probably after finishing this class, you can go back and listen. You can go back and listen. Now we'll continue. We'll continue with the problems. Now we will continue with the next problem. Okay. Now this is, I think this is the previous 2011 problem. 2000, I think this is going to be GATE 2011 problem, which is a very interesting problem. It was asked two questions. It was question 1 and then question 2. Two questions were asked. So now we will see what is saying, sir. The circuit shown below, assume that the voltage drop across a forward bias diode is 0.7 volts. Okay, and the thermal voltage VT is going to be 25 millivolts. That's nice. And the small signal input voltage VI is equal to VP cos omega t, where VP, that is a peak voltage. It's talking about peak voltage. Peak voltage is 100 millivolts. 100 millivolts. Okay. So now what is asking, sir? He's asking two questions. That is the bias current IDC through the diodes. Through the diodes is asking. Okay. So he's asking about diode current IDC and AC voltage VAC. is asking for IDC and VAC. IDC and VAC. Remember, when he's asking very specifically IDC and VDC, when he's asking IDC, you can ignore the presence of the AC, or you can short circuit the AC input. You can see here. Here, the important thing to observe is important you need to observe is you can have, see what is there, sir, here a DC voltage, and here you have a AC voltage. So AC voltage, DC and AC voltage, two voltages are present. Two voltages are present. AC voltage and DC voltage. So when you are asking about IDC, the current IDC, you should ignore this, or you should short circuit this AC input. And when he's asking about AC, you should ignore this DC. You can ignore this DC. Okay, is the point clear? And how many diodes he has given, sir? 1, 2, 3, 4. So 4 diodes he has given. 4 diodes he has given. And there is one resistance called double 9900. That is 9,900 ohms. 9,900 ohms. Okay, and the cutting voltage of the diode is going to be 0.7 volts. Remember this point. 0.7 volts. Now, first we'll try to see what is IDC. So whenever this DC current is applied, so this diode will be having this 0.7 volts. So for DC analysis, what will do, sir? For IDC. So for IDC, so the a very important problem. You can expect same kind of problem in coming days also. For DC, for IDC, so consider DC voltage and short circuit AC voltage. Short circuit AC voltage. Very important, sir. So whenever you short circuit AC voltage and DC voltage is considered, and replace the diode by cut-in voltage. Now what you'll get, sir? How much input voltage you have? Sorry. How much input voltage you have? 12.7 as a DC voltage. Okay. Now you will have it, the 12.7 DC voltage. 12.7 DC voltage. And a resistor you have. A resistor of 9,900. Okay. And then you have 4 diodes which are connected like this, 0.7 volts, 0.7 volts, 0.7 volts, and then 0.7 volts. So this is going to be 0.7 volts. This is going to be 0.7 volts. This is going to be 0.7 volts. This is also going to be 0.7 volts. So 4 diodes are connected in series. So whenever this connected in series, and is asking us to calculate IDC. So if you simplify this, what it is going to be, sir? Or it is going to be very simple. Very simple. So it's going to be 12.7. It's going to be 12.7 volts. 12.7 volts. You have a resistor of 9,900 ohms, and then if you add these 2 points on 1.4, 1.4, 2.8, you'll get. So you'll get 2.8 volts here. 2.8 volts here, and then it's going to be IDC. So what is IDC, sir? IDC is very simple. So this is apply KVL. You will understand. Apply KVL. Understand what you are going to get is IDC. IDC is going to be 12.7 volts minus 2.8 volts by the total resistance in circuit. Total resistance in circuit is going to be 9,900 ohms. So how much it is going to be, sir? I think it is going to be 9.9 volts. 9.9 volts by 9900. So how much is going to be IDC, sir? Very simple. Tell me how much is going to be IDC. Tell me how much is going to be IDC. 1 milliamp. Simply it is going to be 1 milliamp. Are you there? Bharat, are you there? Correct, Bharat. Yes, Bharat. Yes. The answer is going to be IDC is going to be 1 milliamp. IDC is going to be 1 milliamp. IDC is going to be 1 milliamp. Now, next. So what do you need to, sir? We need to calculate VAC. So to calculate VAC, what you need to do, sir? To calculate VAC, what you need to do, sir? You need to ignore or short circuit DC voltage, DC voltage, DC voltage, short circuit DC voltage. So now, if you short circuit DC voltage and you will have a input voltage of 100 millivolts into sine omega t, sorry, cos omega t, and you have a resistor, and these diodes are replaced by their equivalent model. So what are the diodes equivalent models here? Here they need to be replaced by their resistance. They need to be replaced by their diode resistances. So how to calculate diode resistance? So now what we need to calculate is I'm sorry. So this is going to be sine, and it's going to be have a 9,900 ohms. 9,900 ohms is a resistance, and then you are replaced. You should replace all these resistors by their equivalent. They must be replaced by their equivalent resistances. So this is going to be RD dynamic resistance, dynamic resistance, and you're going to have 100 millivolts into cos omega t, 100 millivolts into cos omega t. So how to calculate this RD, sir? What is the RD formula? RD is equal to, can somebody tell me what is the RD formula? Did you remember this? Eta Vt by IDC, eta Vt by IDC, eta Vt by IDC, eta Vt by IDC. So how much IDC we got? We got 1 milliamp. Are you listening or not? Are you there? So eta is equal to, assume eta is equal to 1. Eta is equal to 1. He has given the value of Vt. Vt is at 25 millivolts he has given. But now we got IDC is going to be how much? IDC is going to be how much, sir? 1 milliamp. 1 milliamp. 1 milliamp. So what is going to be RD? RD is going to be 1 into 25 into 10 to the power of minus 3 by 1 milliamp. So 1 into 10 to the power of minus 3. So this will get cancelled. What you are going to have, sir? 25 ohms. So this is 25, 25, 25, 25, 100 ohms here going to be. So equivalent circuit is going to be how much, sir? This is the V input. This is the V input. This is going to be 9,900. This is going to be 100. It is asking us to calculate the voltage drop across this point. Yes or no? What is asking? Is he asking VAC or not? Voltage drop across this point, VAC. He is asking voltage drop across this point, VAC. So how much is going to be VAC? Sorry. So to calculate VAC, what you need to do, sir? Right? So first consider this complete resistance. So V output is going to be this RVA. I'll write VA is equal to V input into its corresponding resistance 1,100 by 9,900 plus 100. So how much is this V input value, sir? What was the V input value? We got is going to be 100 millivolts into cos omega t into 100 by how much you got, sir? You got 1,000, 10,000. So two zeros will get cancelled here. So here 2 zeros will get cancelled. Here 2 zeros will get cancelled. So what will be remaining, sir? 1 millivolt cos omega t is going to be the answer. 1 volt. So VA is going to be how much? I'll write here. So VA is going to be 1 cos omega t millivolts. 1 cos omega t millivolts. Remember this point very clear. Remember this point very clear. Sir, whenever you have, is asking us, whenever he's giving a combination of AC and DC, whenever he's giving us a combination of AC and DC, remember, RD will be 24. Why 24, appa? Why 24? Simply eta Vt by Id. Eta Vt by IDC, na? Bharat. RD is going to be eta Vt by IDC. IDC, how much you got? How much you got, sir? IDC will be 1 milliamp you got. So eta Vt by I, eta Vt by I, that is IDC. So eta into Vt is thermal voltage. How much is given? 24 is given. 25 is given, right? 25 is given. We have taken it from the problem, Bharat. Bharat, we have taken it from the problem. If it have given 26 millivolts, we have taken 26. If we have given 24 millivolts, we have taken 24 millivolts. Is that clear? Is that clear, Bharat? Is the point clear, Bharat? So eta is going to be 1. So Vt is going to be 25 millivolts and Id is going to be 1 milliamp. 1 milliamp. So you need not worry. You need not worry. So remember how the procedure is. So whenever is given both input sine wave and here the options are IDC. How much we got? 1 milliamp. So option A is the right answer, and we got 1 cos omega t millivolts is the right answer. B. So for this question, A is the right answer. This question, B is the right answer. B is the right answer. Okay. So A is the right answer and B is the right answer for this kind of questions. This is the previous question. So tomorrow you may ask you same kind of problem in the given GATE examination. So get ready. Get ready to answer this question. Very simple question this is. It's going to be very, very simple question. This is going to be very, very simple question. Okay. So shall we move on to the next problem? Move on to the next problem. Okay. Now you should calculate this. The circuit shown, assume that the diodes D1 and D2 are ideal diodes. Okay. The average value of VAB in volts across terminals A and B. Across terminals A and B. Okay. VAB is asking. So I think we have done some same kind of problem, but it is not same, sir. It is not same. It is different. So we have earlier I think we have conducted some diodes and capacitors, and we asked you to calculate this in the previous class. In the previous cases, I think we have done this kind of problem, but not on diodes D1 and D2. And D1 and D2 are in the same direction. So now here the D1 and D2 are in the opposite direction. D1 and D2 are in opposite direction. D1 and D2 are in opposite direction. Now pay attention here. Now, so what is asking for average voltage VAB, average value of VAB. So voltage across this is going to be now. Now for the positive half cycle, now I will try to answer here itself. Sorry. So for positive half cycle, now positive half cycle, what happens, sir? Diode D1 and D2 status. First thing what we need to do, sir, in case of diode circuits, you should see what happens to diodes D1 and D2. You should see what happens to diodes D1 and D2. Diodes D1 and D2. So why this Pavan and Jhansi or people are not there? Why these people are not there? Are they busy, occupied with some other work? Okay. Now, so for the positive half cycle of the input, now what happens, sir? The positive half cycle, now what happens? Diode D1 will be conducting. Diode D1 will be conducting and D2 will be off. So I can say D1 on and then D2 off, D2 off. Now if you look at the equivalent circuit, how it looks like, this point A goes here, this is short circuited. I will try to draw, this is on and this is going to be off. It's going to be on and off. So for the V input, positive half cycle. Now you can see what happens, sir. I'm sorry. This diode is short circuited and this diode is open circuited, and this is going to be resistance R1. It's going to be plus and then minus. It's going to be VAB. Then this is going to be 10K, and this resistance, you can see 10K and 20K. This is going to be 20K. It's going to be again 10K. So is it okay? Is it coming now? Oh, I think there will be some technical issue. There might be some technical issue. Sorry. I think there was some technical issue by YouTube. So shall I repeat from? Shall I repeat this? So we are just talking about what happens for the negative half cycle of diode D1 and D2. So now what happens, sir, when diode D1 is off and D2 is on, you'll get the equivalent circuit like this, and you're going to have minus and plus. You're going to have minus and plus. Minus and plus. Now this is going to be 110K. This is going to be another 10K. This is going to be V2. So now what happens, sir? What happens, sir? Your VAB is now this. Are you able to now listen or not? Are you able to listen? Am I audible now? Now, so here you are going to have for the first optical going to be VAB. This is going to be VAB now. Now VAB is what, sir? This is going to be A. This is going to be B. This is going to be plus. This is going to be minus. Plus and minus. This is going to be plus and minus. So now for the negative half cycle, now what happens, sir? Again here the voltage drop across this will be same. Parallel. So now it's going to be VAB is going to be how much, sir? VAB is going to be how much? So V in into 10K by 10K plus 10K. It's going to be V in by 2. Shall I write V in by 2? So VAB is going to be, so 6 pi sine omega t by 2. It's going to be how much, sir? It's going to be 3 pi sine omega t. 3 pi sine omega t. So what is asking, sir? What is asking? 3 pi. So what is asking, sir, is asking the average value of VAB. Average value of VAB. Sir, is it not VDC? What is asking is it not VDC? Is it not VDC? The average value is nothing but VDC. So VDC is how will conduct get, sir? So this VDC is going to be VDC for positive half cycle, and then VDC for a negative half cycle. So what is this, sir? Is that not Vm by pi? Is that not Vm by pi plus Vm by pi? Oh, acha, you want to see how the output looks like? You want to see how the output looks like? I'll show it here now. So you not worry. You not worry here. I'll try to draw the output waveform, how it looks like. So if you look at this, or the output waveform, I'll try to draw the output waveform, sir. You need not worry. I'll show here. So for the positive half cycle, you can see here, for the positive half cycle, what was the peak? It's 2 pi sine omega t. So for the positive half cycle, you'll get an output like this. But for the negative half cycle, it's going to be 3 pi, sir. Yes or no? For the negative half cycle, it's going to be 3 pi. 3 pi. So it will be bit bigger. For positive half cycle, again this is going to be there. For negative half cycle, what happens, sir? Again it is going to be big. So this is going to be 3 pi, this is going to be 3 pi, and this is going to be 2 pi. It will be 3 pi and 2 pi. Now what is the value? What is going to be value? So simply it's going to be 2 pi by pi, 2 pi by pi plus, I'm sorry, it's going to be 2 pi pi, it's going to be 3 pi by pi, it's going to be 3 pi by pi. So pi will get cancelled, pi will get cancelled. What you will get, sir? 2 plus 3. So how much is going to be the value, sir? 5 volts. Very simple. So VAB average is going to be 5 volts. So for the given problem, if you look at the given problem, what is asking, sir? Is asking for the average value of VAB, which is going to be simply 5 volts. It's going to be 5 volts. Are you able to understand or not? Hope this point is very clear for you. Hope this is very clear for you. Hope this is very clear for you. So if you have doubt, please post me the question. Otherwise, I'll go to the next problem quickly. We don't have time. We don't have time. Shall I go to the next problem? Shall I go to the next problem? Okay then. Okay, Bharat, we'll go to the next problem. Yeah. See this problem. Another important problem. So in the circuit shown, assume that the diodes D1 and D2 are ideal. The steady state condition of average voltage across 0.5 microfarads capacitor. Where is the 0.5? This is a 0.5 micro. This is going to be the 0.5 microfarads capacitor. And here it is a 1 microfarad capacitor. Sir, this is the same circuit which we have discussed. You need not worry. In the previous class also we have discussed same kind of circuit. Now I'll try to draw the equivalent circuit. Once I draw the equivalent circuit, you will feel that, sir, we have discussed same problem. At least you will get some idea about this. You will immediately come to know what is this kind of circuit is. Sir, as I told you, whenever you see a diode and capacitor, you should remember that this is going to be a clamper. This is going to be a clamper, yes or no? So many a times I told you, whenever you see this diode and a capacitor, remember that it's going to be a clamper. 50 sine omega t is here. It's going to be 1 microfarads capacitor. 1 microfarads capacitor. And this is diode D1, diode D2, and then this is going to be C2, which is going to be 0.5 microfarad capacitor, and the voltage of across is going to be, I think he said A is going to be B, and is going to be VAB. So now what, sir? So now we will discuss. We will divide the circuit into two pieces and we'll discuss. We'll divide the circuit into two pieces and we'll discuss. See now how I'm going to decide is, now I am dividing this circuit into two pieces. So this part and then this is going to be part 1, part 2. It's going to be part 1. I am saying this is going to be part 2, and I am going to call this as the V01. This voltage I am going to call this as a V01. V01 is the input to part 2. V01 is the input to the part 2. Are you able to understand or not? Are you able to follow me or not? Quick answer is required. Quickly type it. Sir, need the response from all of you. Yes, Bharat. Good, Bharat. Good. So what type of clamper is that? Negative clamper or positive clamper? Tell me. We have discussed in detail about this kind of problems in previous cases. Negative clamper or positive clamper? Till this point, part 1. Okay, no problem. I'll discuss part 1. Part 1. So see how this circuit looks like. So the current what we have discussed here always yes it's positive clamper. Correct. Correct. So what we discussed here always assume that the direction of the current should be in the direction of the diode making on. So when the diode will become on, sir, when this negative cycle, the negative half cycle, the negative half cycle. So now the diodes will the capacitor will charge. The diode is on. The capacitor will charge up to the peak value of the input voltage. What is the peak value? So this is going to be VC. So VC is going to be how much, sir? 50 volts. So it will be 50 volts. So what's going to be V naught 1? What's going to be V naught 1? So V naught 1 is going to be V in plus VC. V in plus VC. So what is V input? What is V input, sir? 50 sine omega t, 50 sine omega t, 50 sine omega t. And then what is the VC? 50 volts because it charged. Sir, in detail I'm not discussing how it is charged, but just we have as we have discussed many times in the previous cases, I'm just coming back and saying this. Okay. So now this is going to be 50 volts. Apply KVL, you understand. Apply KVL, you understand. Okay, simply apply KVL, understand minus plus, and then V01 plus minus. So V01 is going to be, so V01 is going to be V input plus, it's going to be V input plus VC. V input plus VC. So it's going to be plus VC. This is going to be V01. This is the input to what? This is the, sorry. So now you can see. So it means this is going to be a positive half cycle. So sorry, it's going to be positive. So what is the peak value of this? What is the peak value of, sir? This is going to be 50 plus 50. And this is going to be minus 50 plus 50. So positive peak is going to be 100 volts. Are you getting or not? What I'm saying? 0. So as this is a peak, positive peak and negative peak, this is going to be a positive clamper. Positive clamper. So in the case of positive clamper, this is going to be how much, sir? It's going to be 100 volts. 100 volts peak. This is going to be how much, sir? 0 volts. Actually, I think it should touch the 0 volts. It should touch the 0 volts. Sorry. So this is what the now input. This is what the input towards. This is going to be sorry. It is going to be input towards this second part 2. So now we'll see what is part 2. So for part 2, so you are going to have a V01 and then diode, and then you have the capacitor here, and then so you're asking VAB is point A, and then this is going to be point B, and some capacitor is going to be 0.5 microfarads. I'll write here 0.5 microfarads capacitor. So this is going to be, so which is having full positive. So 100 volts here and 0 volts here. Now you can see here. Now you can see here the beauty here. So for when can diode becomes off? Now we should consider the status where diodes is start conduction. Sir, everything is positive half cycle. Everything is positive half cycle. When everything is positive half cycle, diode is always conducting. Means you will have a short circuit like this. A short circuit like this. Now what capacitor starts doing, sir? Capacitor start doing the charging. How much voltage you can charge? What can the peak value of the input? What can the peak value of the input? For that the capacitor can charge this 0.5 microfarads. Are you able to understand or not? So what is the peak value? This is going to be Vm. So the voltage across this 0.5 capacitor, 0.5 microfarads capacitor, I should say this VAB is equal to VC steady state. As the diode is always on, the capacitor charges the peak value of the input voltage. Capacitor charges to the peak value of the input voltage. Yes, that is on. The capacitor charges to peak voltage. So how much is the peak voltage, sir? Is it not 100 ohms? 100 volts? So VAB steady state, VAB steady state is going to be how much, sir? 100 volts. Correct, Bharat, you are right. So answer is 100 volts. Very simple. Answer is very simple. It's going to be 100 volts. Answer is very simple. It's going to be 100 volts. Is the point clear? Shall I go to next problem? Shall I go to next problem? Yeah. This is another beautiful problem. This is another beautiful problem which was asked in the previous gate, I think. So what are you asking, sir? You're asking us to calculate V naught output voltage and current I. Output voltage and current I. This is very important. Yeah. Now we'll consider case by case and we'll see. So here what happens, sir? There is a possibility that the three diodes you have in parallel. Three diodes in parallel you have. Three diodes in parallel. When three diodes are in parallel, there is a possibility that either this diode D1 becomes on, D2, D3 off, or D2 on, D1, D2, D3 off, or all diodes becomes on, all diodes becomes off. So always how many possibilities, sir? Each diode can become on and off. So how many combinations you can have? You can have 8 combinations. You can have 8 combinations total. Total. But is it possible to have all the combinations? Is it possible to have all the combinations? Let all are on. All on. All diodes are on. So when all diodes are on, just for imagining, assume all of them are on. This is 2 volts, this is 3 volts, this is 4 volts. So at this point, right? So here from this you will get 2 volts. I mean, I'm saying it's going to be 2 volts, 3 volts, 4 volts. You have a confusion. You have a confusion. You have a big confusion here. You have a big confusion here. So which one is going to be output? No doubt it's going to be I. What is 8, Bharat? What is 8? You're saying the answer is 8? No, Bharat, no. In parallel case, there should be only one voltage. Otherwise, it is not obeying the Kirchhoff voltage rule KVL. It is not obeying the KVL. In parallel branches, always the output voltage should be same. Yes or no? Or these D1, D2, D3 are in parallel or not? D1, D2, D3 are connected in parallel. D1, D2, D3 are connected in parallel. Yeah, okay. Total number of combinations, yes. Total number of combinations, yes. Okay, understood, Bharat. I am sorry. Okay, we'll move on. So as it is violating that all diodes are on. So all diodes are on is a wrong combination. All diodes are all in a wrong. If all diodes are off, is the possibility of all diodes are off? When all diodes are off, the output is going to be 0. It's also not possible. At least one diode, at least two. Let's say 2 diodes are on. Let's say 2 diodes are on. Now consider, let's say this diode D1 is on. Let D1 on. So when D1 on, what happens here? You have a short circuit like this. This is the 2 voltage you have. I'm sorry. So here you have a 3 volts diode. And here you have a 4 volts diode. Is this possible, sir? Let's say this is going to be 2 volts. So when this is going to be 2 volts, how much voltage you have? 2 volts here. And here also you have 2 volts, yes or no? Sir, when these 2 volts, these 3 volts and 4 volts, for anode of the diode D2, For the anode of D2, you have 3 volts and the cathode is 2 volts. Again, this D2 becomes on. Again, this D2 becomes on. And this is going to be 4 volts and 2 volts. Again, this D2, D3 becomes on. So this combination is also wrong. So D1 on is wrong. D1 on is wrong. Now let's say D2 is on. D2 is on. When D2 is on, what happens, sir? Assume D2 is on. Are you able to understand or not? It's going to be 2 volts, 3 volts, 4 volts. Here, let's say here it will be 3 volts. So when it is 3 volts, here it will be 3 volts. Of course, this is off. Okay, it's going to be off. Okay, but what about this diode D2, D3? D3 again, this is also not possible. This is also not possible because anode of the diode is 4 volts, cathode of the diode is 3 volts. So again, what happens, sir? D3 becomes what happens, sir? D3 becomes on. This is also not possible. So you have one more combination. Simply one combination you have. That is, assume this D3 is on. Only D3 is on. When only D3 is on. Only D3 is on. Now what happens? We'll see. Now only D3 is on. What happens? We'll see. Correct, Bharat? Your response is correct. Correct, Bharat? Your response is correct. But let us see the final value of this. So this is going to be 2 volts. This is going to be 3 volts. This is going to be 4 volts. When this is on means, so how much voltage you have, sir? Here you have 2 volt, 4 volts. 4 volts. So when here is 4 volts, now here also you'll have 4 volts. Here also you'll have 4 volts. Now what happens, sir? This diode D1 becomes off. D2 becomes off. Only diode D3 becomes on. D3 becomes on, and which will obey the KVL. Now, if you look at the equivalent circuit, so this is going to be 4 volts. Here you are going to have 4 volts. When this is 4 volts, this is also V0 is also 4 volts. And what is asking, sir, is asking to calculate the current I. So how much resistance he has given? Let's say it's going to be 1K. Assume it's going to be 1K if it's not given. Let's say 1K here, resistance value 1K. So V0 is going to be 4 volts and I is going to be V0 minus 0 by 1K. So I is going to be 4 volts by 1K. So I can say I is equal to 4 milliamps. I is going to be 4 milliamps. Correct, Bharat? I is going to be 4 milliamps is the answer. I is going to be 4 milliamps is the answer. I is going to be 4 milliamps is the answer. Shall we move to the next problem? Shall we move to the next problem? Very quick problem we will try to solve. Yeah, this is a beautiful problem which was asked in some GATE, I think previous GATE examination. 10 sine omega t, 10 sine omega t, 10 sine 314 t. Omega is given 314. You have what is asking, sir? Is asking voltage across the resistance R. Resistance R. Option A, option B, option C, option D. Can somebody guess what is the option? What is the right answer? As it did not give cut-in voltage, assume cut-in voltage. Assume cut-in voltage. Assume V cut is going to be 0 volts. Assume V cut is going to be 0 volts. Very simple, sir. Very simple problem. Very simple problem. You can guess the answer. You can guess the answer. Bharat, what would be the answer, sir? What would be the answer, Bharat? A, B, C, D. Tell me which is going to be the answer. A, B, C, D. Guess the answer. Guess the answer. Simply, I'll tell you, sir. I'll tell you simply now. I'll tell you the answer. So for positive half cycle, for positive half cycle, for positive half cycle, B is the answer. No, I'll tell. So for the positive half cycle, what happens, sir? This, let's say diode D1 and D2, diode D1 and D2, right? So diode D1 is going to be, let's assume that the diode D1 is going to be short circuited, and for what voltage this diode becomes D2 becomes either diode. See, for positive half cycle, what happens to diode D, sir? D2 becomes either off or in breakdown. Either off or in breakdown. Whenever this is off, whenever diode D2 is off, D1 is on, not possible. So both diodes will be off and output is going to be 0. Right? If the diode D2 is in breakdown, see D1 off, D1 on, and then D2 in breakdown. D2 in breakdown. So when the diode D2 is breakdown, now what happens, sir? You will get voltage like this. So it's going to be 4.1 volt, and is it going to be V output? This is going to be V input. So this is possible only when V input is greater than 4.1 volts. Bharat, just wait for a second and see the answer. Just wait for a second and see the answer. So for V input greater than 0.7 volts, is going to be 10K, it's going to be V naught. So for V input greater than 4.1 volts, so V output is going to be V input plus, sorry. So apply KVL. Apply KVL. So it will be V input minus 4.1. Minus 4.1 volts. So what can be the peak value of this? What can the peak? It's going to be 10 sine omega t, which we have written. 10 sine omega t minus 4.1 volt. 4.1 volt. So for peak value, so peak value is going to be, V output is going to be 10 minus 4.1, which is going to be how much, sir? 5.9 volts. 5.9 volts. So similarly for negative half cycle, what happens, sir? Similarly for negative half cycle, what happens? Sorry. Similarly for negative half cycle, what happens? For negative half cycle and diode D1 is in breakdown, D2 is in. So now, so how it looks like, sir? Let's say for positive half cycle, for V input is going to be, let's say let's say 7 volts. So for 7 volts, so V output is going to be 7 minus 4.1. 7 minus 4.1. How much is going to be this? 2.9. So your output is going to be like this. Till the 4.1 volts, your output is not there. So from again, it's going to be there like this. So here it's going to be 5.9 volt. So ideally, the input voltage is like this. So which is going to be 10 volts. Are you getting or not? Are you getting or what? You want me to draw in a different color? I'll draw it in a different color. For positive input, you'll get like this. So for negative half cycle, what happens, sir? For negative half cycle, what happens, sir? For negative half cycle, for negative half cycle, for negative half cycle, assume. Now what happens, sir? D1 should be in breakdown. D2 should be off. D2 should be on. So now what happens, sir? On means short circuit. Short circuit. So what happens, sir? It should act like a voltage this, and then short circuit, and then you'll have a 10K. Then you'll have a 10K. It will be minus plus, plus minus. It will be minus plus minus. So V output is going to be again what? V output is going to be, simply you'll get a negative half cycle. Negative half cycle. Negative half cycle. So shall I draw directly? This is going to be V input. So V output is going to be V input minus this again 4.1 volt. Or sir, if you consider this going to be minus plus, so it will be minus plus, minus plus, and then plus minus, you'll get in a different way. If you want to do it, or what happens, sir? It's going to be, if you want to write minus of minus, you'll get minus plus. Minus of minus, you'll get plus. So here what is going to be minus 10 sine omega t plus 4.1. It's going to be V naught. So what is the V naught maximum for negative half cycle is going to be minus 10 plus 4.1. It would be minus 5.9 volts. So how the output looks like, sir? How the output looks like? Now tell me which one is the answer. Which one is the answer? Now tell me which one is the answer. A, B, C, D. Are you getting sine wave or square wave or triangular or only this one? Bharat, what is the answer? What is the answer, Bharat? What is the answer? A. Correct, Bharat. Answer is A. Answer is A. Are the problems, are you enjoying the problems or not? See, you need to enjoy. You should enjoy. You should fight. You should fight like anything. So these are the important problems which were asked, which were asked, which were asked previously, which were asked previously. Okay, need energy, need lot of energy. Okay, Bharat. Now we'll see this problem. Now we'll see. Try to analyze this problem. Now we'll try to analyze this problem. He's asking us to calculate the V naught value. He's asking us to calculate the V naught value. Same analysis what we have done in the previous case, you should do the same thing here. Same analysis which you have assumed. So assume first all of them are on. Is it possible to have all of them are on? Is it possible to have all of them are on? No. As it is not possible to have all of them are on. Now at least we should assume that any one of them is on. Any one of them is on. So how can you feel that which one is going to be on? Which one is going to be on? So for negative half cycle, V may be greater than. No, it is not going to be V, sir. Yes, V is going to be minus 10 sin omega t. Minus 10 plus what is going to be minus 10? Minus 10. I'm sorry. Bharat, it's going to be minus 10 is going to be minus 10 is the maximum. When it minus 10 is maximum, this plus 4.1 volt is the breakdown voltage of the diode D1. Then what happens? So if you think this is going to be, sir, I'm talking about negative half cycle. Negative half cycle. Negative half cycle. It's going to be negative half cycle. I'm talking about minus 10. So you can also talk, you can take always, like let's say minus 7 volts you can take. If it is going to be V output, it will be minus 7 sin omega t plus 4.1. Again, what you'll get, sir? So it will be minus 2.9 you get. So how the output will be? Output will be. So if your input is like this, your input is like this, the output is going to be like this, Bharat. Are you getting the point or not? It's going to be minus 5.9. It's going to be minus 10 volts. Okay. Okay. Now here, what we need to, sir? Anyway, we know that all of them will not be on. All of them will not be on. So what happens in case of previous case? In case previous case, what we thought that 4 volts diode was on. Now, if you assume that this 4 volts diode is on here, if you assume that this 4 volts diode is on here, so if this is going to be 4 volts, this is going to be 4 volts. Now, what happens that D2? Assume that this is going to be D1, D2 will come in reverse way. In reverse way. So 4 volts. So if it's going to be 4 volts, diode D2 will also on, D1 will also on. So our assumption of D3 on is going to be wrong. So simply directly jump into assume D1 is on. When D1 is on, what happens here, sir? You're going to have 2 volts. When it's 2 volts, so when it's going to be 2 volts, now what happens, sir? It's going to be 2 volts. Now what happens? Diode D1 is on. When diode D1 is on, now what is the voltage across this, sir? Again, this is going to be 2 volts. This is also going to be 2 volts. So which will makes D2 off as well as D3 off. So when both diodes D1, D2, D3 off, so what will be remaining, sir? You will have 2 volts here. So what is the output voltage? Very simple. Output voltage is going to be 2 volts. Output voltage is going to be 2 volts. Is the point clear? Very simple, sir. Correct. Correct, brother. D2 and D3 are off. D2 and D3 are going to be off. When D2 and D3 are off, D1 is on, and output is going to be simply 2 volts. There is no possibility of becoming D2 on or D2 off, D3 on. So only D1 will come on and D2, D3 will be off. So this is going to be the output voltage. So this is assume that this is going to be D1, D2, D3, D4. So find out what is going to be the output voltage. What is the output voltage across WX? So consider this as a homework. Consider this as a homework. Consider this as a homework, sir. Consider this as a homework. And why is that? That is the voltage applying across this 10 sin omega t. Assume simply for positive half cycle. For positive half cycle, what is the status of diode D1, D2, D3, D4, D1, D2, D3, D4, and calculate a corresponding output. For negative half cycle, calculate what is going to be D1, D2, D3, D4, and find the answer. Find the answer. Very simple. So what happens? Shall I tell you the answer? Shall I tell you the answer? Let's say for positive half cycle, what happens here? Positive half cycle means it's going to be at 10 volts here. 10 volts here, it's going to be minus negative voltage. Positive voltage is negative voltage here. So D1 is going to be off. Are you getting the point or not? D2 is also off. So now D3, what happens, sir? Negative voltage are applying. So it's going to be off again. This is D4 is also going to be off. So when all the diodes are off, all the diodes are off, this is WX is going to be, what is the voltage drop across this? No current is flowing across the 1 ohm resistor. Same voltage is here. When no voltage is flowing across the 1 ohm resistance, now what is the voltage, sir? So corresponding VWZ is going to be VWX is going to be 0 volts. 0 volts. Now consider the other way around. For negative half cycle, what happens, sir? For negative half cycle, diode D1, D2, D1 is on, D2 is on, D3 is on, D4 is also on. Now when all of them are on, now what happens, sir? Are they not short circuited? Simply consider here, sir. This is short circuit and this is short circuit. D3 and D4 are short circuited. When D3 and D4 are short circuited, what's the voltage drop across these two? 0 and 0. So what is the voltage drop across 1 kilo ohm resistance? Again, here also VWX is going to be 0 volts. Are you getting the point or not, Bharat? This is very important. So for negative half cycle, all the diodes will become on. And all the diodes are become on, they will be short circuited. So whatever voltage across these 2 points, WX, same voltage will be across this 1 kilo ohm resistance. So same voltage will be across this, right? So this is on, this is on. So these two D3, D4 are short circuited. When D3, D4 are short circuited, so what is the voltage of across these two? D3, D4, 0. So again this is going to be 0. So end of the day, for any condition, for any condition, so this is going to be 0 volts. For any condition, it's going to be 0 volts. Okay. Okay. We'll catch up in the next class. We'll start next course. I mean, next part of this analog electronics crash course, BJT. Don't miss tomorrow's class. Don't miss tomorrow's class. Okay. Thank you, Bharat. Thank you for attending. And before that, just listen to me what I'm saying. So I'm going to post this notes in Unacademy Gate English Telegram channel. Telegram channel immediately. Telegram channel immediately. And then these are the different YouTube channels which we have. Creatics Gate WE ECE IN, Unacademy Gate ME PIXE, and that is mechanical production engineering and engineering sciences, Unacademy Gate for civil engineers and chemistry, chemical engineering, Unacademy for computer science. Of course, is also useful for IT, instrument, information technology. You have Unacademy Gate question, exclusive Gate questions are available, and you have something called electrical junction, Unacademy Gate English, where I am talking about. And these are different classes, and this poster will change. It's going to be 3:30 p.m. Okay. 3:30 p.m. So for diode problems, you can use Boyle set. But for diode problems, you can use Boyle set. Is a very good book for different questions. Different questions. Better you always choose IES or GATE previous questions. Also, they'll give you lot of information. Lot of information. Okay. The Naishwara sir is teaching communication systems. Venkata sir is teaching engineering mechanics. Engineering mathematics. Again, one more engineering mathematics to target 2020-2023. And the foundation course for aptitude was taken by Sharma sir. And Surendra sir is taking measurements. And Banu sir is taking electrical machines. Don't miss this. Okay. Thank you. But don't forget to like, share, subscribe, and press the bell icon. Right? We'll catch up in tomorrow's class again at 3:30, sir. Tomorrow again at 3:30 p.m. We'll catch up. We'll catch up again at 3:30 p.m. Thank you.